Welcome to week 4 of Death 101. Thus far, we have covered the rapid improvements in global mortality, particularly from communicable and childhood conditions. And we've also covered the emergence of non-communicable diseases and key risk factors such as smoking and binge alcohol. So in this week, we're going to focus on how to count the dead reliably so as to measure changes in global mortality. To do that, we're going to start back in history. So let's start by first covering a fatal outbreak of cholera in London about 200 years ago.
To learn about the history of epidemiology, we're going to take a look back at a gloomy, cramped, and very likely damp London, England, in August of 1854. The now famous Soho district was enjoying a stint of infamy during a terrible outbreak of cholera, a bacterial infection which turns the bowels to liquid, inducing vomiting and diarrhea. In 3 days, 127 people died in Soho, many fled the area, and within a week and a half, the death toll had climbed to 500. Enter the hero of our story, John Snow. From humble beginnings as the son of a coal miner, John Snow was apprenticed to a surgeon as a boy and went on to study medicine. He became a pioneer in medical hygiene and the use of anesthesia. At the time, your average William and Harry thought cholera was spread by bad air or miasma. This was a vestige of an age-old paradigm in medicine dating back thousands of years to ancient Greece, China, and India. John Snow had other ideas, though. As a doctor, he had treated many patients without getting cholera himself, and by 1849 he developed a theory that cholera was instead transmitted through contaminated water. At the height of the Soho outbreak, as others were fleeing, our man John Snow took it upon himself to walk straight into the thick of it all and find a solution. He began his investigation by talking with Soho residents, and soon determined that most of the infected people had drawn water from the same well. The source of the outbreak was a single water pump on Broad Street, now known as Broadwick Street. He convinced city officials to remove the pump handle, preventing further consumption of its contaminated water, and infections and fatalities immediately plummeted. The final toll of the outbreak was 616. John Snow also systematically mapped out the location of all the recorded Soho cholera deaths, confirming the pump as the locus of infection. This map kick-started the field of medical geography, confirmed John Snow's theory of waterborne cholera transmission, and eventually contributed to evidence for the germ theory of disease. These contributions to science have cemented John Snow's reputation as the father of modern epidemiology.
So why is John Snow important? Well, his story is a microcosm of the central theme of our course, which is using data to study disease so as to prevent or to cure it. Snow challenged the commonly held assumption that cholera was something that appeared by magic or by air by using scientific evidence. What Snow did, as you saw in the video, was look at the patterns of where the cholera deaths were occurring and then link it back to that famous pump on Broad Street. Now, where did Snow get his data? Now, that's a really important question, and to answer that, we have to go back 200 years earlier, or more than 200 years earlier, to the first, what's called the Bills of Mortality, that started being registered in different parts of London starting in the 1600s. Around 1660, a young London haberdasher named John Grant wrote a book which was called Natural and Political Observations Made Upon the Bills of Mortality, where he described the patterns of deaths from these small areas and also described the numbers of births and deaths that had occurred. And John Grant famously described what is probably the first verbal autopsy, which again you'll hear about later, which involves sending teams out to these small areas, taking notes of what had happened in the deaths, interviewing the houses or the people who had registered the deaths, and then putting all of this together. And from this he created the first life tables. John Grant didn't define demography. He didn't know what that term is, but he is basically the first person who did demographic studies of this kind. Now, this caught the attention of King Charles II because he was interested to know what was happening in inner city London, which was very dense at that time. King Charles also wanted to know how many able-bodied men that he had available to fight wars. And John Grant developed the basic idea of counting how many people lived in different homes and led to one of the first census efforts to try to figure out where people lived. But his most important contributions were simply understanding how people die. One of the things that was commonly held at that time was that, well, the leading cause of death in London is murder. But in fact, John Grant showed that 10% of the deaths occurred from tuberculosis, or what is called consumption at that time, and that deaths in infancy, early on in life, were actually very common, and that deaths from murder were actually quite less common. And this had an impact on how governments and King Charles himself thought about organizing what they could do. So we owe a lot to John Grant's simple observations as probably the first demographer for tracking disease and tracking how people die. That enabled subsequent discoveries such as John Snow, and as you'll learn later, discoveries such as smoking being linked to lung cancer increases, and more recently, HIV/AIDS deaths. So the world owes a lot to John Grant.